Alright, so we will be finishing Newton's laws today. Recall that Newton's second law states that an unbalanced force will cause a mass to accelerate, and we used our formula F equals ma, or A equals F over m, rearranged. So let's just put a big 2 beside here to remind us, okay, that's Newton's second law. Newton's first law states that an object will remain at a constant velocity unless acted on by an unbalanced force. Or we can call this the law of inertia. Inertia means the tendency for an object to remain at that constant velocity. So it's basically, I don't know, you can kind of think about it like it's holding that energy. It's the ability to resist a change. So we also, when we think about Newton's law, we have usually heard it in this form. An object that is in motion will stay at motion, and an object at rest will stay at rest. So this is when we usually think of Newton's first law. So if you want to, you could memorize that, and that kind of helps you to remember Newton's first law, and then just relate that to inertia. This is all about inertia. So, for example, when riding in a car and the driver slams on the brakes, the passengers will slide forward. Because the passengers were initially moving at a certain velocity, and then the car stops. Well, the people in the car will continue to stay at the velocity that the car was going before. And so the car stops and you go forward because your body wants to stay at that same velocity, but the car has stopped. So the passengers, then we would refer to them that they want to retain inertia. They want to maintain the same velocity that they were going. Another example is, say you're traveling in a car and the passengers again are going at the same velocity. When you turn a corner, you have a tendency to lean because your body wants to continue to go that original motion. So say we're driving along going forward and my car turns this way. My body wants to continue going forward, so as my car goes this way, my body's going to end up leaning this way. So whatever is in the vehicle wants to maintain the same direction it was going. If the vehicle changes direction or stops, then any object in the vehicle will just continue on its same path, and so it will appear to be leaning. Another example, say you're in a vehicle and you're going at, say, you're just cruising, say, at 53 kilometers an hour. Then all of a sudden you accelerate and you lean back because you've just accelerated. Because you want to go at the same velocity you were just going. Your body wants to stay, say, at 53 kilometers an hour. As soon as the car goes faster, your body is at a slower velocity. Okay? It wants to maintain that inertia. It wants to maintain that slower velocity, so it goes back because it hasn't caught up yet to the velocity of the car because it is now accelerated. Now, Newton's third law of motion, so let's put a big 3 by here. Did we put a 1 here? Yeah, we did. So Newton's third law of motion states when an object exerts a force on a second object, the second object exerts an equal and opposite force on the first. So let's just use, let's say, object A and B. So let's say we'll call this the action force. The force initiated by object A on object B. So that's the initiation. This is the first action. So when we call it for every action, that's here, there is an equal but opposite reaction. Okay, so now let's do the reaction force. So this is the force exerted by an object, oh, sorry, by object B, from this same scenario on object A. So this action force is this here, and this opposite reaction is the reaction force here. So we always see these paired together. You can't have an action without a reaction. It doesn't exist. With every action there is a reaction. So when we look at Newton's laws, the first two laws are really when we deal with objects just kind of in isolation by themselves. The third law is all about interactions.
In the conference room.
The third law is all about interactions and what happens when objects interact with each other. This is always what happens when objects interact with each other. It will obviously look different depending on what objects they are and their acceleration, their mass, etc. But for every action there will always be an equal and opposite reaction. Okay, so let's think about a baseball. Let's draw a bat here. And a baseball coming in, hitting the bat. So if I was to draw kind of my free body or my vectors of the force, what's happening here, is that the bat is going to be hitting the ball. And the ball will be hitting the bat. So I can therefore conclude that my force of my bat is equal